All right, guys, so now the next part that I want us to look at is limiting regions. Okay, I want us to do a bit of revision from grade 11 because I know that limiting regions, it's actually required in this section, and some of you might have forgotten it. So I want to try and see if we can master it. So limiting regions, okay. So essentially, the way I like to look at limiting regions, once again, the recipe. You're told you need to put 2 spoons of oil, 1 spoon of sugar, 3 spoons of this and that. But, or actually, very simple example, Eros and water. There's a certain amount of Eros and a certain amount of water that you like to put to create that wonderful tasty juice. But what if you put too much of Eros? What if you have too little of Eros? So that's kind of what limiting regions is. But let's look at it in this aspect. First of all, you've got a reaction. A plus B makes C and D. Remember what I said, if there's no number in front of each molecule or compound, it basically means that there's a 1. So 1 mole of A reacts with 1 mole of B to form 1 mole of C and 1 mole of D. So if you look at these examples, there's 3 scenarios that I've written here. 1 mole of A, 1 mole of B. What is that going to form? 1 mole of C, 1 mole of D. 1 mole of A reacts with 1 mole of B, that forms 1 mole of C, 1 mole of D. Now what I want you guys to look at is the fact that we have no moles of A and no moles of B left over. Literally all of A is finished, all of B is finished. Okay, why? Because we had equal amounts of A and B. They basically reacted with each other. But now let's look at scenario number 2. 1 mole of A reacts with 1 mole of B, which will form 1 mole of C and 1 mole of D. But now we have B. But what does B need? B needs A, but we don't have any of A left. B is not just going to react alone and suddenly form C and D. It needs a mole of A because that is the recipe that we see over there. But here, we don't have enough of A. A is completely finished before we were even able to react with B. So what does this tell us? This now tells us that A is the limiting regions. The way that I like to think about it is that A limits the reaction, right? This reaction could continue. If we had another A mole, A would react with B and then form C and D, but we cannot. We only have 1 B mole left. A is gone, and therefore we say A is the limiting regions. It limits our reaction. It is the reactant that is completely consumed when the chemical reaction is complete. Like it literally just ends the whole reaction. It limits it from continuing. Situation number 3. 1 A mole, 1 B mole form C and D. 1 A mole, 1 B mole form C and D. What's next? We do not have a B mole. Okay, we don't have 1 mole of B to react with that 1 mole of A, which means that B is the limiting region here. B is the one that limits our reaction. Okay, so I want you guys to look at the fact that in all of these situations, I know I'm drawing the moles out, but it's grade 12, guys. You cannot draw it out every time, especially if you have a situation where they tell you that the number of moles of A is like 0.00756 moles. You can't draw that out every time. So what we're about to do is we're going to master how can you do that with calculations. Okay, so before we go on to how you can do that with calculations, let's look at how it relates to acids and bases. Same situation. Okay, I wrote it down. Okay, very, very simple number of moles.